would happen if an asteroid the size of a 20-story building hit our moon? As you may already know, the 2024 YR4, which recently alarmed scientists and spread uncertainty about Earth's future, now has an almost zero chance of hitting our beloved planet. However, our moon is still in the crosshairs. So, what would happen if it actually struck the moon? What would be the massive impact for us here on Earth? Asteroids, although much smaller than planets, are by no means harmless, especially to us humans. Most of them are located in the asteroid belt between Mars and Jupiter. However, the real concern for this video are those with orbits that can intersect with Earth's, and YR4 is the largest ever recorded. This is where scientists come in. They constantly monitor these objects. While the chances of an impact are almost always small, we can't take any risks because any shift in trajectory could have enormous consequences. An example? The famous asteroid Apophis, when discovered in 2004, had a 2.7% chance of colliding with Earth in 2029. Although that threat has also been dismissed, it will pass just 31,000 kilometers away from us, even closer than some satellites. This close approach could alter its orbit due to Earth's gravitational pull, changing its future path. That's why scientists keep monitoring it and will continue even after it passes by. On December 25th, while Earth was celebrating Christmas, a peculiar visitor appeared on scientists' radar. A rocky asteroid with an estimated diameter between 40 and 90 meters, YR4 may not be gigantic, but it carries enough energy to cause a significant impact. It passed about 829,000 kilometers from Earth, just over twice the distance between us and the Moon. While not an immediate danger, cosmic near misses like this one remind us of the importance of tracking these objects carefully. In fact, it will return once again before the dreaded year of 2032, on December 17th, 2028, but still far enough away. By the way, make sure to subscribe to this channel so this video isn't just a cosmic near miss between us on the internet. But then, how do scientists calculate the odds of a rocky object wandering through infinite space hitting us? Have you ever stopped to think about how impressive that is? Well, scientists use a combination of observations and calculations to map out asteroid trajectories and assess whether they pose any risk to Earth. It all starts with gathering data on the asteroid's position and movement using telescopes and other specialized instruments. With these initial observations, astronomers can understand these celestial bodies' orbits and make predictions about their future paths. Using this information, scientists perform calculations to forecast asteroid paths, factoring in planetary gravity and even how the sun's heat can alter their course, a phenomenon known as the Yarkovsky effect. Through computer simulations, they refine these predictions as new data comes in, adjusting them for greater accuracy. With specialized observatories and NASA programs like the Planetary Defense Coordination Office, scientists not only track known asteroids passing close to Earth, but also search for undiscovered ones. These near-Earth objects, or NEOs, are categorized based on how their orbits behave relative to our planet. To simplify, the two main groups are Apollo asteroids, which cross Earth's orbit but stay farther from the Sun than Earth does, and Aten asteroids, which are closer to the Sun but cross Earth's orbit during their trajectory. These classifications help scientists assess potential risks. Now that we understand what asteroids are and how scientists calculate their paths, what would happen if our only natural satellite were hit head-on? For those who don't remember, the Moon has no atmosphere. This means it would be directly struck by the asteroid without any protection. Such an impact would release a colossal amount of energy, creating a crater between 500 meters to 2 kilometers in diameter. To give you an idea, that's the size of large football stadiums or up to two 20-story skyscrapers side by side. The influence on Earth would be indirect. As we all know, the Moon controls our tides. A change in its size or surface structure, though not immediate, could eventually cause slight shifts in our tidal patterns. Nothing apocalyptic, but something worthy of scientific investigation, since tides could become stronger or weaker, depending on how much material is displaced by the collision. The impact would also produce debris, but it's unlikely that any would reach Earth. And if they did, our atmosphere would mostly burn them up. On the other hand, this event would be a unique opportunity for scientists to study the Moon in new ways. Research on lunar composition could reach an unprecedented level of detail, as the crater would expose layers of the surface previously hidden. Moreover, it would be a chance to learn more about how space impacts affect rocky bodies. Valuable knowledge for future missions to the Moon and other planets. However, if YR4 were truly on a collision course with the Moon, scientists would probably prioritize defending the satellite over studying the aftermath. But the question is, with today's technology, would that even be possible? Currently, there are four main ways to attempt to deflect an asteroid: using a spacecraft or a design device to collide with it, like NASA's DART project, which has already been tested; a gravity tractor, where a spacecraft uses its gravitational pull to gradually alter the asteroid's path; a nuclear explosion near the asteroid, which could fragment and push it away; or solar lasers, still in development, which work by heating the asteroid's surface to propel it in a different direction. Each strategy has its advantages and challenges. The best option would depend on factors like available time, the asteroid's composition, and the resources at hand. And of course, it would require a global effort. A question you might be wondering about is, would this impact be visible to the naked eye from Earth? The impact would produce a very intense flash of light, which in theory could even be seen during the day, depending on the moon's position and observation conditions. However, this visibility would rely on perfect atmospheric conditions at the time. Furthermore, YR4 would kick up a massive cloud of lunar dust, which, due to the lack of atmosphere, would float for quite some time before starting to settle. With today's advanced telescopes, though, any event of this scale would be recorded with impressive precision. Perhaps even NASA astronauts and those from other space agencies could be sent to investigate the site and conduct field experiments on the moon's new formation. For now, there's no reason to worry while these impact chances remain low. Space is under constant watch. This year, the James Webb Space Telescope will closely monitor YR4, studying its composition and trajectory with great precision. Meanwhile, the moon remains eternal and watchful, still a silent potential victim of the cosmic stories unfolding around it.